satisfied from the fossil fuels such as coal, oil, natural gas, as well as nuclear, hydro energy, solar, and wind energy. But fossil fuels remains the dominant source of energy production, accounting for a major share of electricity generation and industrial fuel. If the tremendous use of energy increases, then total energy will get exhausted within the next 60 years. So, due to industrial urbanization, their fossil fuels going to tremendous use of fossil fuels. So that's why maybe in next 60 years it will be depleted. So there are two type of energy sources: non-renewable energy sources and renewable energy sources. So in the non-renewable energy sources included the uh, crude oil, natural gas, coal, peat, radioactive metals, and hydrocarbons like fossil fuels. So these non-renewable energy sources obtained from the nature and will get depleted because of most of the 90% energy production depends upon non-renewable energy sources. In contrast, the second one is the renewable energy sources, including the hydroelectricity, tidal energy, geothermal energy, wind energy, solar energy, and biomass. So these renewable energy sources also obtained from the nature, but it will not get depleted. But nowadays only 10% energy production depends upon the renewable energy sources. So if you see in this graph, so more than 90% energy sources are obtained from the non-renewable sources, and only just 10% energy sources are utilized from the renewable energy sources such as solar energy, geothermal, biomass, wind, biofuels, and hydropower. So, in the nowadays, most of the electricity is produced from the fossil fuels. So, in fossil fuels, including the coal, crude oil, natural gas, and from the fossil fuels, there produces electricity. So, in this case, their most topmost is China, then United States, then India, Russia, Japan, Saudi Arabia, Korea, Iran, like this one. So most of the countries there depends only upon fossil fuels. So that's why in coming decades, due to rapid increasing the industrialization, world will have to be faces two main challenges. One is a global clean energy crisis, and another one is the environmental pollution. So that's why for overcoming to these problems, researchers from worldwide have devoted their major efforts to finding substitutes for energy crisis, that is renewable energy sources such as solar energy, then wind energy, hydrothermal energy, tidal energy, biomass, biofuel energy, and hydrogen energy is one of them. So, hydrogen energy, most of the researchers focuses on hydrogen energy and how it should be produced or how it should be utilized for domestic as well as industrial purposes. So, hydrogen is a highly desirable substitutes for fossil fuels to solve the energy crisis as well as to solve the environmental problems because of hydrogen energy, which offers advantages such as source of hydrogen is easily available, that is water, and is abundantly available on planet or earth. Okay, second one, it gives high fuel efficiency. It is a non-polluting environmental friendliness. It is cost effectiveness. It not emits hazardous greenhouse gases when used in fuel cell, that is net zero carbon emission. It is a renewable energy sources. It is more efficient than other sources of energy as compared to fossil fuels. It is a non-toxic, and when it is used in fuel cell, byproduct is just water. So these type of advantages are found in hydrogen energy. So that's why hydrogen energy nowadays they call as a green energy. So as compared to fossil fuels or gasoline, with respect to energy content, vehicle efficiency, and combustion engines in fuel efficiency, hydrogen gives a lot of advantages because of if you consider the energy content, 1 kilogram hydrogen has about produce 120 megajoules of energy. That is 33.3 kilowatt hour, means it almost three times greater than fossil fuels or gasoline. For example, 1 kilogram of gasoline if burn out, and they produce approximately 40 megajoules of energy. So approximately 11 kilowatt hour. So if you consider the vehicle efficiency, if hydrogen or gasoline, if they're used in combustion engines, so fuel cell, generally hydrogen is used in fuel cell, and whenever it is used fuel cell, then efficiency it gives 50 to 60%. That is about 100 to 120 kilometer per hour if 1 kilogram hydrogen is used in a fuel cell. But in contrast to this hydrogen, there if you use gasoline like petrol, diesel, so the combustion engine efficiency is about, they gives 25 to 30%. So there along with the fuel cell, they're possible to use hydrogen in internal combustion engines. Most of the researchers now, they are focuses hydrogen, they're used in internal combustion engines also. So suppose hydrogen, if they're used internal combustion engines, so they produce 50 to 60% efficiency, approximately 100 to 100 kilometer per kilogram of hydrogen. They gives average if their vehicle, if they're used. So in contrast to this hydrogen fuel, if they use gasoline, like presently we are going to use gasoline like petrol, diesel, so 20 to 35% engine efficiency only gives, means approximately 10 to 15 kilometer per liter they gives. And also they emits hazardous gases like CO2, CO. But whenever hydrogen is used without any CO2, they gives 100 to 120 kilometer per kilogram. Okay, so this type of advantages are found whenever hydrogen is used in internal combustion engines as well as fuel cell. So there are have a lot of applications apart from the fuel or fuel cell. They shows they gives the various applications in chemical industries as well as energy sectors, food technology, metallurgical, transport, electronic industries. Okay, so if you see in transport sector, if the fuel cell is used in vehicles such as buses, trucks, uh, trains, ships, even aircraft also for clean energy. So they're possible to use direct hydrogen also in internal combustion engines. So also their hydrogen is used in power generation. In hydrogen also is used in fuel cell, and turbines can generate electricity with water as a byproduct, as well as it is used as renewable electricity, and which can be produced by electrolysis, which is later used in generate power, which helps to balance the power grid. So they're possible to generate electricity in large scale with the help of fuel cell, and it maintain the balance of power grid also. Okay, so hydrogen also used in petroleum refining industries, because of in petroleum or crude oil there contains sulfur as a main constant. Sulfur or sulfur containing products, which is impurities, are present in petroleum or crude oil products. And for removal of these sulfur containing products, there also hydrogen is essential one. So in petroleum refining, hydrodesulfurization, there is a catalytic chemical process used to remove sulfur compounds like thiol, sulfides, disulfides, and thiophene from petroleum. So apart from fuel or fuel cell or energy sector, this hydrogen is also used in petroleum refining industries. Then ammonia production is one of the largest industrial uses of hydrogen, and it's mainly done through the Haber-Bosch process. So in Haber-Bosch process, there ammonia is produced from nitrogen and hydrogen, and hydrogen provides the reducing agent in needed to combine with nitrogen. Without hydrogen, they're not possible to synthesize ammonia. Currently, 70% of global hydrogen production is consumed in ammonia plants. Okay, so in ammonia is used in fertilizers like synthesis of urea in large scale. This urea is mostly nowadays are used as a fertilizer in every crop plants. So urea, ammonium nitrate, ammonium sulfate. So for synthesis of the fertilizers as well as chemicals like plastic or explosives in textiles, energy carriers. So in all applications, their hydrogen is essential one. So also hydrogen is used for methanol production. So methanol nowadays are used also their fuel, as well as it is used in various paints, plasticizers also, adhesive also. So for methanol production, generally methanol nowadays are obtained from the ethanol obtained from the fossil fuels. But this methanol also they're possible to produce by this by using of hydrogen. So methanol, this methanol is used in plastic paints, adhesives also. So metal industries. So hydrogen also reduces the metal ores like iron, which replacing the coal coke. So in metal industries, their coal coke is used. Uh, in, for example, in traditional methods of blast furnace, iron ore is reduced using coke, which is a carbon source, and then after pure iron metal obtained, and this CO2 is hugely um, uh, reduces hugely in environment. Okay, so but in contrast to this traditional method, if their hydrogen based reduction method is used in metallurgical industries or metal industries, then it is a very sophisticated. Hydrogen acts as a reducing agent, and this hydrogen is here with us instead of coal or coke, and then they obtain the pure metal also. So byproduct just is the water and not CO2. But if you see in this traditional metal industries, traditional method or blast furnace, there's CO2, which is largely produces in environment also. So also their hydrogen is used in chemical industries, which is used as a reactant in making fertilizer, hydrocarbons, hydrogen peroxide, hydrochloric acids, synthetic fuels like jet fuel, aviation industries, lubricant, waxes like high quality base oils, paraffin wax, chemical feedstock like olefins for plastic and chemical. So in the chemical industry, their hydrogen also nowadays are required. Then heating and residual uses, hydrogen can be blended with natural gas. Nowadays, for domestic purposes, we are going to use liquefied petroleum gas. So hydrogen possible to blend with this liquefied petroleum gas for household heating and cooking purpose. In future, also pure hydrogen possible to use for domestic purposes. So in also their hydrogen is used in electronic industries like semiconductor industry, used as a reducing or cleaning agent. Rocket fuel, liquid hydrogen combined with liquid oxygen is a high efficiency of rocket propellant. Cooling medium in power stations, also their hydrogen is used as a cool generators, for cooling generators. Okay, so these are the applications. So apart from fuel or fuel cell, there are a lot of applications are found in every industries. So that's why hydrogen is essential one. So, but here now question is arise that how they produce hydrogen. Natural their hydrogen found very less, but in our planet have their God gift, that water is a God gift, and with the help of water uh, and sunlight, they're possible to produce hydrogen. So water hydrogen will be produced by water splitting. So water splitting means what? So water splitting means to produce hydrogen and oxygen by using of specialized semiconducting photo or electrocatalyst, or sometimes photoelectrocatalyst in presence of sunlight or electricity, or sometimes both are used. So here from water molecule their hydrogen they're possible to separate with the help of sunlight or with the help of electricity and with the help of catalyst. Sometimes sunlight and electricity both are used, and this electricity is used in this case renewable energy sources. For example, solar energy, they're possible to use electricity in this case, and then they will split water into hydrogen. So there are various types of water splitting, and through the water splitting, they're possible to generate hydrogen in large scale also. So first one is the electrolysis of water. So in this electrolysis of water, their electric current is used. Electric current as well as catalyst is also essential one. So electric current. Second one is the thermochemical water splitting. So in the thermochemical water splitting, there only temperature is required. Sometimes temperature or along with catalyst, they're also required in thermochemical water splitting. Third one is the photobiological water splitting. So in this photobiological water splitting, they're used light or photon energy, light along with some bacteria, enzymes, or microorganisms are required. Then fourth one is the photoelectrochemical water splitting. In the photoelectrochemical water splitting, they use current and light energy also, or photon, so called as a photoelectrochemical water splitting. And last one is the photocatalytic water splitting. In this photocatalytic water splitting, their light as well as catalysts are required. So photocatalytic water splitting. So in laboratory on large scale, there these possible ways are used to produce hydrogen from water, so called as a water splitting. So first one we'll see in detail electrolysis of water or electrocatalysis of water. Water splitting means what? So in the electrolysis or electrocatalysis water splitting, their hydrogen will be produced by using of electricity as well as catalyst. So in this case, their water splits into hydrogen and oxygen by using of electricity as well as catalysts. Their catalysts also they are required. So their hydrogen and oxygen will be produced after the splitting of water with the help of catalyst electricity, so called as electrolysis or electrocatalysis of water splitting. The in this electrolysis or electrocatalysis water splitting, the hydrogen gas evolved at the cathodic and simultaneously oxygen gas also evolved at the anodic compartment. Okay, so if you see in this schematic diagram of electrocatalysis water splitting, so this one is the water in this compartment or in an electrolyzer. Their water, either acidic water, alkaline water, or neutral water, they're possible to use, and this water splits with the help of electricity, external electricity here with provided electricity as well as catalyst there. Okay, so at the cathodic end, generally there at the cathodic end, the reduction reaction takes place, and due to reduction reaction, the hydrogen gas evolved from the cathodic compartment or from the cathodic electrode. Simultaneously, the oxygen also evolved from the anodic compartment or anodic electrode. So at cathodic electrode, the reduction reaction takes place. For example, in acidic medium, in acidic medium means their pH is less than 7, 6, 5, 4, 3, 2, 1, or sometimes their use nitric acid or sulfuric acid, HCl, there also their use at high dilute acids are used to convert water into acidic medium. So acidic medium, generally their hydrogen gas evolved by twice H plus twice electrons. So these electrons accepted from the external circuit or electron they're supplied, therefore called as electrolysis or electrocatalysis. Here external source required, external current here is provided to the cathode anode. So at the cathodic here, hydrogen gas evolved from the cathodic by accepting electrons, or in alkaline conditions, here S2 plus twice electron, S2 hydrogen gas evolved in alkaline. Alkaline conditions means greater than, sometimes we want to maintain the pH greater than 7, like 8, 9, 10 by using of NaOH, KOH, or sometimes alkaline medium greater than pH. In molar condition, we want to also evolved hydrogen. So at the time of acidic condition, if their hydrogen gas evolved, same time here at the anodic compartment, here oxygen is evolved by this reaction. So S2 plus O2 plus twice H plus twice electrons. So in this case, here oxidation reaction takes place at the anodic compartment. Same time, here twice H plus are formed, and to these H plus ions again travel from the anodic to cathodic compartment through the membrane. So this type of mechanism takes place in the water electrolyzer or electrocatalysis water splitting process. Okay, so these both reactions simultaneously takes place. Oxidation reduction simultaneous reaction takes place in this case. In alkaline condition, what happened there? H2O accepts electron, then twice OH minus and H2O here hydrogen gas evolved from the cathodic compartment, and their OH minus ions are formed. These OH minus they travel from cathodic compartment to anodic compartment. So in this case, here twice OH minus, here oxidize and O2 H2O and twice electrons again they form. These twice electron again they travel from this anodic to cathodic compartment. So this type of mechanism or reactions are involved in this electrolysis, water splitting. Means at anodic compartment there oxidation, at cathodic compartment reduction, and due to reduction here hydrogen gas evolve from this cathodic compartment. Simultaneously their oxygen also evolved from the anodic compartment. So generally this type of mechanism takes place in every electrolysis process as well as in photocatalysis process. Okay, we will see in every so if you see in this video, uh, this is a electrolysis process where hydrogen gas evolved. uh, so whatever here catalysis, generally catalysis, synthesized catalysis they coated on the stainless steel or nickel foam material, and this here it acts as a cathodic material. So they're applying external voltage, approximately 2 to 20 electron volt here with apply voltage, and at this voltage here hydrogen gas evolved from the cathodic material. So actually this is a stainless steel sheet, and on the stainless steel sheet they coated the catalyst like TiO2, ZNO, or sometimes composite material they're also coated. Composite nanomaterial they're coated on the surface of stainless steel sheet. So as time increasing or current applying, their hydrogen gas evolved from the uh, cathodic electrode. So here it showing the bubble disbursement of bubble. These bubbles are nothing but the hydrogen gas. So this type of hydrogen gas evolved from the cathodic electrode, and this is possible by using a potentiostat by applying external current. Here it means external current means very few amount of external current, 2 volt, uh, 2 to 20 millivolt. Their current supply at this current, their bubbles are detached. Hydrogen bubbles are detached here. So in our laboratory also we have synthesized one of the TiO2 electrocatalyst, and this TiO2 electrocatalyst coated on the surface of the stainless steel, and this stainless steel they're used as a cathode electrode. As you seen in this video, there this type of TiO2 coated on the stainless steel sheet, and then they're applying voltage, they produce hydrogen gas. Okay, so we have sorry we have synthesized TiO2 as an electrocatalyst, and this sorry, and this electrocatalyst coated on the stainless steel sheet, and this sheet worked as a cathodic catalyst. So the TiO2 synthesized by simple co-precision method. After synthesized, we have characterized by XRD, Raman, same time, EDX, XPS. So this one is a Raman XRD and usable spectra of the synthesized TiO2 catalyst. So this one same time of the synthesized TiO2 electrocatalyst, EDX and XPS. Uh, so generally, platinum or noble metals nowadays are used as a electrocatalyst, and platinum, rhodium, or some of the gold nanoparticles, silver nanoparticle, or mixed nanoparticles are used. So, but they are rare elements, and the cost of the catalyst are very high. That's why researchers are focuses on metal oxides or mixed metal oxides or nanocomposite material used as a electrocatalyst. So TiO2 is one of them, TiO2, ZNO. So this type of catalysts nowadays are used for water splitting technology. So the electrochemical performance check by LSV, CV, Nikos plot, and this work present currently published in scientific report also. So in the electrocatalysis or water electrolyzer, there are five main components as you seen in previous slide: cathode, anode, gasket, bipolar plates, and membrane. These five main components are required in electrocatalytic water splitting technology or hydrogen production by electrocatalysis or construction of an electrolyzer. These five main components are required, like cathode, anode, gasket, bipolar plates, and membrane. If you see in this case, there this one is the anode, this one is the cathode. In between these, the membranes are placed, membrane, gasket, and bipolar plates. Also, they're placed between this anode and cathode electrode. Okay, so in water electrolyzers, the membrane plays very important role because of while oxidation reduction reactions, the H plus ions, OH minus ions, or O2 minus ions, they travels from either anodic to cathodic compartment or cathodic to anodic compartment. So from migration of these ions, their membrane are required. So membrane plays very important role, crucial role in the electrolyzer. So on the basis of membrane, the water electrolyzers are classified as a proton exchange membrane, water electrolyzer, alkaline membrane, or anion exchange membrane, water electrolyzer, diaphragm, porous separator, water electrolyzer, solid oxide electrolyte, water electrolyzer. So on the basis of membrane which are used between the anode cathode compartment, and through the membrane there travels the ions. So on the basis of membrane they are classified the electrolyzer. So electrolyzer means in this case only electricity is used, electricity and catalysis, and with the help of electricity catalysis they produce hydrogen. Okay, so first one is a proton exchange membrane. Proton exchange membrane called as because of proton after oxidation and reduction reaction, proton like H plus ion they travel from anodic to cathodic compartment through the membrane. So therefore this electrolyzer is known as a proton exchange membrane electrolyzer. So this one is a cathodic electrode, anodic electrode, and between these two electrodes there place membrane, and this membrane is made up of perfluorosulfonic acid. Nowadays, like Nafion, Aquan, instead of Nafion, another polymeric material, most of the researchers also focuses on or synthesis various types of membrane for proton exchange membrane, water electrolyzer. So through the membrane, the H plus ions travels from anode to cathodic compartment. So in the water electrolyzer, in presence of electricity, their anodic and cathodic compartment or electrode, their simultaneously oxidation and reduction reaction takes place. Okay, sorry. So at anodic compartment, their water is oxidized and their twice H plus form and electrons are released, and these electrons are travels from to anodic to cathodic compartment, and simultaneously H plus ions also migrate from anodic to cathodic compartment. So in this case, the reduction reaction takes place, means at cathodic electrode or cathodic compartment, their reduction reaction. Reduction means gain of electron. Okay, so here this twice H plus travels from to anodic to cathodic compartment, and this twice H plus this accepts these electrons and their hydrogen gas form, and this hydrogen gas released in this water electrolyzer. So this water electrolyzer is called as proton exchange membrane water electrolyzer because of H plus ions. Protons are travels from or migrate from anodic to cathodic compartment. Therefore, proton exchange membrane. Second one is the alkaline membrane, anion exchange membrane, water electrolyzer. So anion exchange membrane, water electrolyzer. Generally, their oxidation reduction, both reactions are simultaneous place at anodic cathodic electrode or anodic cathodic compartment. So in this alkaline membrane water electrolyzer, at anode, at cathode their OH minus ions form. At cathodic electrode their OH minus ions form after reduction of water molecule in presence of electricity. their S2 means hydrogen gas here with evolved, and they generate OH minus ions, and these OH minus ions travel from cathodic to anodic compartment here. And at anode here, OH minus oxidize into O2 means oxygen here with evolved, uh, along with the water they are also obtained as a byproduct. So alkaline membrane water electrolyzer called as because of OH minus ions here with migrated from cathodic to anodic compartment through the membrane. Therefore, this type of electrolyzer known as alkaline membrane or anion exchange membrane water electrolyzer. Third one is the diaphragm or porous separator water electrolyzer. In this case, their diaphragm like porous membrane is used, like zircon like a material they place between anode and cathodic compartment, and this electrolyzer it works as like alkaline electrolyzer means anion exchange membrane electrolyzer and allows OH minus ion in liquid KOH or NOH electrolyte. So here also alkaline water they're used in this alkaline water electrolyzer as well as in this alkaline membrane water, alkaline anion exchange membrane electrolyzer. Their alkaline water mostly preferred like KOH, NaOH electrolyte solution, which is this electrolyte solution splits into hydrogen, oxygen. Okay, and the last one is the solid oxide electrolyte membrane water electrolyzer. So in this solid oxide electrolyte uh, uh, water electrolyzer, their yttria stabilized zirconia ceramic oxides are used as a catalyst, and they at anodic cathodic compartment their oxidation reduction simultaneously takes place, but their O2 minus ions are formed at cathodic compartment. Their hydrogen or cathodic electrode, their hydrogen gas evolved after reduction, and their O2 minus ions are formed. And these O2 minus ions migrate from cathodic compartment to anodic compartment. So this one is a solid oxide electrolyte which is placed between anodic cathodic compartment, and through the solid oxide electrolyte means yttria stabilized zirconia through the catalyst or solid oxides because of O2 minus they travels from cathodic to anodic compartment, therefore solid oxide they refer the electrolyzer or called as a solid oxide electrolyzer. So in all electrolyzer their oxidation reduction simultaneously takes place, and hydrogen gas generally evolved off from the cathodic electrode. So if you consider or comparison all these electrolyzer like PEM electrolyzer, anion exchange membrane electrolyzer, alkaline electrolyzer, solid oxide electrolyzer. So in this PM electrolyzer, their proton exchange membrane is used, which carries or migrate H plus ion, and their generally naphion or aqueon membrane is placed between two electrodes. In anion exchange membrane electrolyzer, their anion exchange membrane is used, which migrate OH minus ions, and this membrane is synthesized by quaternary ammonium polymers. In alkaline electrolyzer, their diaphragm or separator is used, and through this separator, their OH minus they migrate, and their these diaphragm separator synthesized by quaternary ammonium polymers as like anion exchange membrane electrolyzer. In solid oxide electrolyzer, their solid oxide membrane is used, which travels or migrate O2 minus ion. So yttria stabilized zirconia material they are used, or yttrium stabilized zirconia material, dope cerium also. So this type of material they're used in solid oxide electrolyzer. So second one is the photocatalytic water splitting. Now first one is their electrocatalytic water splitting, and second one is a photocatalytic water splitting. Now photocatalytic water splitting means what? In this case, their hydrogen is produced by splitting of water in presence of sunlight or by using of sunlight and catalyst there. Okay, so in this case there no any electricity required. So without any electricity, without any external current or electricity, just here with used photon or light energy, which is obtained from the sunlight, and catalyst they are used. Okay, and then their hydrogen gas evolved. Okay, so this type of water splitting called as a photocatalytic water splitting. So photocatalytic water splitting, they use only sunlight and semiconducting nanomaterial as a catalyst. So they produce uh, hydrogen and oxygen also. So photocatalytic called as. So in the photocatalytic water splitting, there's semiconducting material or semiconducting nanomaterial they're used as a photocatalyst, which absorb the sunlight and generating electron hole pairs. These drive the redox reactions. Also, the oxidation reduction reaction takes place, but here electron hole pairs are created because of the absorbed sunlight energy. So at reduction means at conduction band, there means in the semiconducting nanomaterial, their valence band and conduction bands are formed whenever they absorb sunlight or photon energy. So at the conduction band means in this case, this is a semiconducting metal. This is schematic diagram of water splitting technology in photocatalytic water splitting. So at the conduction band, their electrons are obtained, which is obtained from the valence band. So at the conduction band, these electrons are accepted by H plus from water, and their hydrogen gas is evolved. Okay, here at the conduction band. Simultaneously, at the valence band, that oxidation reaction takes place. So water is oxidized into oxygen here, and here oxygen evolved in the valence band. So in the photocatalytic water splitting, there is semiconducting photocatalysts are used in presence of sunlight, and then their hydrogen gas is evolved up. Therefore, photocatalytic water splitting called as. So this type of mechanism involved in this photocatalytic water splitting. So semiconducting metal, they absorb sunlight. They absorb sunlight, and then after their electron hole pairs are formed. That is, electrons are get excited from the valence band to conduction band, and their hole remains present in the valence band. So the redox reactions are occurs. That is, oxidation reduction takes place at the conduction band and valence band, and due to the reduction reaction, there here hydrogen gas evolve. So generally, there semiconducting nanomaterials are used in the photocatalytic water splitting, like TiO2, BiO4, tungsten oxides. Okay, so nowadays mostly if you see BiO4, they shows the uh, good band gap between 1 to 2 electron holes. So that along with TiO2 or individual BiO4 also they're mostly used nowadays. Most of the researchers are focuses on bismuth vanadium oxide because of they shows the good band gap as like TiO2, ZNO. Also, the nanocomposite material also they used as a photocatalyst like TiO2 mixed with BiO4, like that nanocomposite material also they're possible to use instead of the noble metal in photocatalytic water splitting. Then third one is the photoelectrochemical water splitting. So photoelectrochemical means what? In this type of water splitting, their hydrogen and oxygen gas both are evolved. Hydrogen, oxygen, both are splits from water, but in presence of light as well as electricity or external current. Means both here with use. Sometimes only just light there produce hydrogen, but along with the electricity and light, their hydrogen evolved rapidly compared to electrocatalysts, compared to photocatalysts. So that's why most of the researchers now are nowadays focuses on photoelectrochemical water splitting. Okay, so photoelectrochemical water splitting is closely related to photocatalyst, but instead of using suspended catalyst powder, it uses as a semiconductor electrodes, photoanode, photocathode. So semiconductor electrodes are used. So catalyst mostly they're coated on the surface of cathodic anodic electrode. So in a photoelectric water splitting, sunlight excites a semiconductor electrode as like photocatalyst, like their valence band, conduction band, their forms, and then the photogenerated electrons and holes drive the hydrogen evolution reaction and oxygen evolution reaction at different electrodes, means at cathodic electrode and anodic electrode respectively. So in the photo electrochemical water splitting, their hydrogen is rapidly evolved off as compared to electrocatalysts as well as photocatalysts. Therefore, photoelectrochemical water splitting nowadays mostly used for production of hydrogen. So in this photoelectrochemical water splitting, at the anodic compartment, anodic electrode, here with N-type semiconductor like TiO2, Fe2O3, BiO4, ZnO, this type of semiconducting material they coated on the surface of electrode, photoanode electrode, and their water is oxidized into oxygen, and then their 4H plus 4 electrons are forms, and these 4H plus electrons they travel from the membrane here uh, towards the photocathode, uh, photocathode, and these at the photocathode or at the cathodic electrode there H plus and accepts electron, then there hydrogen there you are. Okay, so this type of twice H plus twice electrons means these electrons come from the here anodic compartment after oxidation, and H plus also travels from the membrane. So H plus accepts electron, and then their hydrogen gas here with revolve at photocathode. Okay, so in this case also their light energy or photon absorbed by the photocathode, photoanode electrodes, and their photons excite electrons from valence band to conduction band, and at the conduction band their reduction reaction takes place, so their hydrogen gas evolve, and simultaneous charge separation electron minus moves to the circuit. H plus stays at remains present at the semiconductor surface. Okay, so holes oxidize water at the photoanode means O2 released, and at electrons reduce photons at the cathode. So hydrogen gas released in this case photocathode or cathodic electrode. So anode cathode there simultaneously oxidation reduction reaction takes place by using of electricity as well as the photons. So their rapidly hydrogen gas evolved. Therefore, photoelectrochemical water splitting is showing great advantage compared to photocatalytic as well as electrocatalytic water splitting. Then fourth one is the thermochemical water splitting. So thermochemical water splitting is another pathway for production of hydrogen from water, but instead of electricity or direct light absorption, here we just use heat or temperature just is used without any electricity, without any light, just here with temperature or heat is required for water splitting. And so high temperature heat which is obtained from nuclear reactors or solar powers or industrial waste heat, which is this type of heat is utilized for chemical reactions. Generally here series of chemical reactions are takes place, not only just and not as like photocatalyst or photoelectrocatalyst, catalytic water splitting or electrocatalytic water splitting. There anodic cathodic just two reactions that takes place, but here in the thermochemical water splitting there series of reactions are found. Okay, so these reactions indirectly split water into hydrogen oxygen, and after each cycle the chemical reagents are regenerated. So there series of chemical reactions are found. For example, in uh, in sulfur iodide cycle, in the sulfur iodide cycle at 850 degrees Celsius heat they are provided or supplied to the electrolyzer, and there three steps of reactions are involved. Initially iodine is react with sulfur dioxide in presence of water, so their H and H2 sulfur form, and the second step H2 sulfur is decomposed into sulfur dioxide, water, and oxygen. So here oxygen is evolved after decomposition of sulfuric acid. Simultaneously, what happened? This HI is decomposed into iodine and hydrogen. So hydrogen gas here will evolve. Sorry. So in this case, there series of reactions are instead of anodic cathodic reaction here series of reactions are involved, but required their very high temperature. So that's why thermochemical water splitting called as. So net reaction is here hydrogen oxygen here it splits from water in presence of temperature, high temperature or heat. So therefore thermochemical. Another example of hydrogen gas, hydrogen also produced by this hybrid sulfur cycle. Okay, so in the hybrid sulfur cycle, there externally their supply are provided 500 to 600 temperature or heat, and then their sulfur dioxide electrolysis into H2SO4 and hydrogen. So hydrogen gas here will produce, and this sulfuric acid in second step it will be decomposed into SO2, and again their water they are obtained byproduct, and simultaneously their oxygen. So hydrogen oxygen also they are released in the thermochemical water splitting. So just there instead of photon or light energy, instead of electricity or catalyst, just their temperature, high temperature required, and then their water is splits in these reactions into hydrogen and oxygen. Then in this thermochemical water splitting, only heat is required in the cycles. So advantage of this thermochemical water splitting is can use renewable heat, means here heat required, and this heat supply to the reactions from solar concentrators or nuclear heat also. No direct electricity input required, and potential for large scale hydrogen production in the thermochemical water splitting. Okay, then last one is a photobiological water splitting. So photobiological water splitting means what? It is a biological route to produce hydrogen using microorganisms. Microorganisms and light, sunlight here is required. Instead of the artificial semiconductor or high temperature, it uses the natural photosynthesis machinery of algae and cyanobacteria. So in the photobiological water splitting, there just their use the microorganisms or bacteria or enzymes are used in presence of light, and then their water splits into hydrogen oxygen. So this is a photobiological water splitting. So their mechanism involved as, so water is oxidized at photosystem second, means release oxygen, and oxygen and proton H plus ions are released in the photosystem second in presence of light, and then their electrons travel through photons in the electron transport chain. In electron transport chain, the um, electrons are travels, and then in some algae or cyanobacteria, their hydrogenation reaction takes place, means H plus accepts electrons. Whatever their electrons are released, these electrons again accepted by H plus in presence of the microorganisms or enzymes. Then the hydrogen gas is produced. So this type of mechanism, these reactions or mechanism involved in photobiological water splitting. But generally, instead of photobiological or thermochemical, most of the researchers are focuses on electrocatalysis, water splitting, electrocatalytic water splitting, photocatalytic, as well as photoelectrochemical water splitting. Apart from this photocatalysis or catalysis or thermochemical water splitting, there also they're possible to produce hydrogen by steam methane reformation process. So approximately 70% of global hydrogen is produced by this steam methane reformation. So here with methane is hydrolyzed in presence of water, in presence of the catalyst at high temperature. So there carbon monoxide and hydrogen gas is evolved. But in the steam reformation process, mostly there is carbon monoxide and carbon dioxides are produced in environment along with the hydrogen. Also, their hydrogen is produced by coal gasification. At hot coal, through the hot coal, there passes the steam of water, and then their hydrogen is also produced. So coal gasification there also possible to hydrogen. But in these two methods, steam methane reformation and water and coal gasification, there CO2 and CO. Compared to CO2, CO is mostly hazardous because of it binds easily with the iron of the hemoglobin. So possible to clot the blood. So that's why CO2 and CO, these two are very hazardous gases. Also, they are produced along with the hydrogen in the steam methane reformation and gas coal gasification. So these are some types or methods, and with the help of method, they're possible to generate hydrogen. Uh, uh, and these hydrogen is used in domestic as well as industrial purposes also. So uh, then second part of this topic is a fuel cell. So fuel cell is a very important one nowadays. Most of the transportation, their fuel cell are used. Fuel cell and lithium ion battery. This type of battery or fuel cell used in generally in transportation. Okay, so fuel cell means what? So it is an electrochemical device where hydrogen and oxygen is used, and then they generate electricity, and this electricity is used for transportation purposes. Okay, so the fuel cell is an electrochemical device that generate electricity through an electrochemical reaction. Electrochemical reaction means there again oxidation reduction takes place, as like in electrolyzer. In water electrolyzer, their oxidation reduction, redox type of reaction takes place, and then their hydrogen gas is evolved, and this hydrogen is used for domestic industrial purposes. So in the fuel cell, there also redox type of reaction takes place. There also anodic cathodic reaction takes place, and these reactions are called as a electrochemical reaction. But in the fuel cell, without any combustion, means there no any, just like in internal combustion engines, there a direct fuel is used, like petrol, diesel, kerosene, or some other gasoline products are directly used in internal combustion engine. For example, in four-wheeler, two-wheeler, that petrol, diesel, kerosene, these are used, and then there generate electricity or heat energy. Okay, so without any combustion, in this case, just they produce electricity with the help of hydrogen and oxygen. So in a fuel cell, hydrogen and oxygen both are used, and they then they generate electricity. So after in this fuel cell, just they obtain water as a byproduct without any hazardous byproducts. So generally in traditional fuel like wood, coal, peat, dung, or some of the fossil fuels, after burning or combustion, they produce hazardous gases like CO2, CO, nitrogen oxide, dioxide, sulfur dioxide, trioxide. These type of hazardous gases are continuously emits while burning of the traditional fuels. But in the fuel cell, their hydrogen is used as a fuel, hydrogen, green hydrogen, which is produced by the steam reformation or coal gasification or water electrolyzers. Their hydrogen gas is produced. Okay, and this hydrogen here is used as a fuel, chemical fuel or fuel. And with the help of oxygen, here hydrogen is completely combust, and then they react with each other, and then they produce electricity. And their water, just water obtained as a byproduct, water and small amount of heat also they produce in this fuel cell. So just water is obtained as a byproduct instead of hazardous gases. So in a ordinary combustion fuel process means their wood, coal, peat, charcoal, dung. These are solid fuels. Similarly, liquid fuels like kerosene, diesel, petrol, or alcohol-based fuels, or gaseous fuels like biogas, coal gas, water gas. Okay, so in the traditional fuel, they contain carbon as a main constant. Okay, and this carbon burns in presence of oxygen, and then they produce heat, large amount of heat, and this heat will be utilized for domestic or industrial purposes. But along with heat, they release large amount of CO2, CO, or in this fuel contain there suppose sulfur, nitrogen in some amount, also there sulfur dioxide, peroxide, nitrogen dioxide, trioxide. These gases are released. So these gases are hazardous one into the environment as well as human being. Means to the planet, these gases are our global warming, you can say as. So CO2, CO, or NOx, SOx, these hazardous gases also produce on burning of fossil fuels or traditional fuels. Okay, so their oxygen required for burning of the fuel, and they produce heat as well as some of the hazardous gases CO2, CO. But as compared to traditional burning process or combustion process, if you see in fuel cell, they're also used fuel, but in this case, in a fuel cell, their hydrogen is used as a fuel instead of coal, instead of coke, instead of petrol, diesel, kerosene, or other fossil fuels. In this case, only their hydrogen is used in this fuel cell, and hydrogen react with oxygen in presence of oxygen. Then they produce electricity. Okay, therefore electricity and their water obtained as a byproduct. Just water they obtain in the form of steam, or water they obtain as a byproduct. So without any hazardous other polluting elements or other polluting gases, here would only just obtain water as a byproduct. and they produce as well as electricity, and this electricity possible to use industries as well as transportation, means various sector they used electricity, okay, or grid to balance the grid, their electricity. This type of electricity is used with the help of this fuel cell. So the main components are fuel cell. So fuel cell is constructed by using of anode, cathode, electrolyte, and catalyst cell. So as like water electrolyzer, in water electrolyzer, there hydrogen gas produced by water splitting. Okay, so water electrolyzer called as. But in a fuel cell, in this this is an means electrochemical device also. Water electrolyzer also electrochemical device, fuel cell is also electrochemical device, because of in presence of electrolyte solutions or electrolyte there produce, or their oxidation reduction at cathodic anodic in their oxidation reduction takes place, therefore electrochemical device called as. So in the fuel cell there five major components are required, like anode, anodic electrode, cathode, anode, cathode, or anodic electrode, cathode electrode. Between these to place their membrane also, as like electrolyzer there. In this case also their membrane is used, because of membrane. Without membrane they're not possible to generate hydrogen, oxygen, because of to migrate an ions, either cations, anions. Their membranes are essential one. So anode, cathode, and membrane. And then bipolar plates also there. Bipolar plates are between two their electrolyte solution, and catalyst. Catalyst also they plays very important role. So catalyst also they coated on the cathodic electrode as well as anodic electrode and external circuit. Okay, so these components are present in the construction of fuel cell. These are major components, along with the some of the supporting components also there. Bipolar plates, gas diffusion layer, end plates. These are end plates, gasket sealing also they required, and cooling water management system. So these are supporting components also required in the construction of fuel cell. So in a fuel cell, there electrochemical reaction takes place, like oxidation reduction, and at anode there oxidation reaction takes place, means this is a fuel. Now in a fuel cell, their fuel hydrogen is used as a fuel, and oxygen is used as oxidizing agent, okay, in this fuel cell. So hydrogen here, with hydrogen is oxidized at anodic compartment or anodic electrode. Their hydrogen is oxidized, and then their H plus ions and electrons are released. Okay, this type of oxidation reaction takes place at the anodic compartment or anodic electrode. Simultaneously, at the cathodic compartment, the reduction reaction takes place as O2 plus 4H plus, whatever the H plus ions or cations are formed, plus electrons. Electrons also release electron. They travel towards the cathodic compartment. So these electrons are accepted by the H plus ions, and then their water there formed. So oxidation reduction reaction, these both reactions are occur simultaneously at the anodic cathodic compartment respectively, and then they produce electricity. This type of electricity they produce. Okay, and their water, just water obtained as a byproduct. So this type of reactions are involved in a fuel cell. So there are generally four or five types of fuel cell. On the basis of electrolyte solution, their fuel cell they classified as alkaline fuel cell, then molten carbonate fuel cell, then solid oxide fuel cell, phosphoric acid fuel cell, polymer electrolyte membrane fuel cell. So these are some major types of fuel cell. On the here with in a fuel cell also their external temperature also required, temperature. So on the basis of temperature also they classified as a low temperature fuel cell, then moderate temperature fuel cell, high temperature fuel cell, very high temperature fuel. Between 50 to 100 degrees Celsius, there if their temperature required. Electrolyte solution, their external temperature also provided to the electrolyte solution. So that's why on the basis of temperature they classified as so if they're in between 50 to 100 degrees Celsius temperature they're required to the electrolyte solution or to the fuel cell, then called as a low temperature fuel cell. 100 to 250 degrees Celsius if their temperature also required or provided, then called as a moderate temperature. Then 250 to 500 degrees Celsius, if the temperature provided to the electrolyte solution or to the fuel cell, then called as a high temperature fuel cell. And greater than 500, generally 500 degrees Celsius, if the temperature provided to the fuel cell, then called as a very high temperature fuel cell. So on the basis of temperature, on the basis of electrolyte solution, they are classified fuel cell into the alkaline molten carbonate, solid oxide, phosphoric acid, and polymer electrolyte fuel cell. So if you see the alkaline fuel cell, so in an alkaline fuel cell generally it is called as a H2O2 fuel cell also, H2O2 fuel cell. And this alkaline fuel cell known as a Bacon fuel cell also, because of this invented by British scientist Francis Thomas Bacon. Therefore, firstly invented by this scientist. Therefore, Bacon fuel cell also called as. Okay. So in this alkaline, along with the alkaline fuel cell, their phosphoric acid fuel cell also there have been invented. And in Apollo mission, their alkaline fuel cell in 1960 they are used. Firstly, they utilized this alkaline fuel cell. Okay, so alkaline phosphoric acid fuel cell they mostly used by astronauts in space mission. Also, NASA they used alkaline and phosphoric acid fuel cell. So in the alkaline fuel cell, they use hydrogen as a fuel, and oxygen, pure oxygen as an oxidizing agent or oxidant, and then they produce electricity and heat. So electricity is main purpose. To produce electricity is the main purpose of fuel cell. And instead of hazardous gases, they are often water as a byproduct. Simple mechanism involved in this fuel cell is their hydrogen gas is used as a fuel. As like in traditional fuel, their wood, peat, dung, coal, or petroleum products or gasoline products are used. These traditional fuels are similar to that. In that fuel cell, their hydrogen is used as a fuel or chemical fuel called as. Hydrogen is used as a fuel, and this hydrogen combines with oxygen, or in presence of oxygen, this hydrogen is oxidized, and then their electricity or electrons are generated, and these electrons are captured or utilized as an electricity. Okay, so in an alkaline fuel cell, if you see in this is a schematic diagram of alkaline fuel cell. So construction of alkaline fuel cell, if you see, so this is a anodic compartment or anodic electrode, which is made up of porous carbon material. Similarly, cathodic electrode also they used carbon material, porous carbon material, and on the surface of porous carbon material, there also their coated catalyst like iron oxide, nickel oxide, copper oxide, some of the gold nanoparticle, silver, platinum nanoparticle like that, or mixed metal oxides or nanocomposites. Most of the researcher now focuses on nano composite catalyst. Okay, so in alkaline fuel cell, their platinum is used. Platinum powder is used as a catalyst, which is coated on the porous carbon material or anodic material, porous anodic material, or cathodic material also. Between two, they place alkaline solution between two electrodes. These two electrodes coated by the catalyst, fine powder of platinum, and between two electrodes, they placed alkaline solution. So that's why the alkaline fuel cell called as here with alkaline solution, like 70% NaOH, KOH solution they're used between two electrodes, and then the oxidation reduction reaction simultaneously takes place. So at the anodic compartment, the oxidation reaction takes place as means uh, through the anodic compartment here hydrogen gas is supplied. Okay, hydrogen gas, and hydrogen gas is oxidized due to anodic compartment or anodic electrode. Here hydrogen gas oxidized, and H plus twice H plus uh, uh, sorry, in this case, so at anodic compartment here hydrogen gas is oxidized in presence of OH minus ions. In presence of OH minus ions means in alkaline condition, because of between two electrodes they're placed electrolyte solution, alkaline solution, NaOH, KOH, either NaOH or KOH, dilute NaOH, KOH solution they're placed between two, or alkaline medium solution they're placed between two electrodes. So in presence of alkaline condition means OH hydroxyl ion presence. So in presence of OH minus, hydrogen gas is oxidized So their water molecule form, and simultaneously their electrons are produced. Electrons after oxidation. Oxidation means loss of electron. Here hydrogen gas oxidized and electrons are released. And these electrons, they travel from anode to cathodic compartment through the external circuit. Here electrons are travel from anode. So while traveling electrons, these electrons utilize or capture as an electricity. While traveling electrons from anodic to cathodic compartment, these electrons utilize as a electricity. So these electrons, they reach on the cathodic compartment, and on the cathodic compartment or cathodic electrode, the reduction reaction takes place. Reduction means from the right hand side here. If you see in this diagram, from the right hand side here, supply oxygen, oxygen gas, pure oxygen. Okay, here pure oxygen here used as an oxidizing agent or oxidant. So oxygen here is supplied from the right hand side compartment, and left hand side here hydrogen supplied as a fuel. Okay, so this fuel is oxidized here with, and then their electrons release after oxidation of hydrogen in presence of OH minus. Electrons are released, and these electrons travel from anodic to cathodic compartment, and these electrons, they are accepted by oxygen. Oxygen here, electrons accepted here oxygen, and then there in presence of water, again their OH minus form. Okay, so these electrons accepted by oxygen in presence of water. Here, water also, because of dilute NaOH means water molecules are present. So in presence of water, this oxygen accepts electron. So again, their OH minus form. Okay, again their OH minus, and this OH minus, again they travel from anodic compartment to cathodic compartment to anodic compartment. So here OH minus is a charge carrier ion. OH minus, they worked as a charge carrier ion. Again the OH minus, they travel through the membrane or electrolyte solution toward the anodic compartment. In presence of OH minus, again their hydrogen is oxidized. Again their electrons released. 4H plus ions form. Again electrons released. Again this electron travel from anodic compartment. So this type sorry, this type of reactions, oxidation reduction reaction, continuously takes place. While while redox reaction, their electrons are released and electrons are utilized as an electricity. So in this way, by oxidation reduction reaction, here by oxidation reduction reaction, their electrons are released, and these electrons are used as an electricity in a fuel cell. And net reaction or all reaction, their water, just water, they obtain as a byproduct. So in fuel cell, they produce electricity, okay, or generate electricity by oxidation reduction reaction. By oxidation reduction reaction, they produce electricity. So reverse reaction takes place in the fuel cell. Generally in water electrolyzer, there also oxidation reduction reaction takes place. So generally reduction at cathodic. Similarly in this case, in fuel cell, reduction reaction cathodic, on the cathodic compartment electrode, the reduction reaction takes place. But in a fuel cell, there supply hydrogen, and in water electrolyzer, their hydrogen gas is produced, means hydrogen is released in water electrolyzer. Okay, previous one, hydrogen gas is produced by photocatalytic water electrolyzer, electrocatalytic water electrolyzer, then photobiological water, thermochemical water electrolyzer, like that. Okay, so in the water electrolyzer, there hydrogen gas or hydrogen gas produced or hydrogen splits from the water. Okay, but in this case, in a fuel cell, their hydrogen is supplied or used as a fuel, and with the help of oxygen, their produce electricity, and then their water obtained as a byproduct. Okay, so this water electrolyzer and fuel cell both are contrast to each other. Okay, so this type of reaction involved in alkaline fuel cell, and then they produce electricity as well as water, they obtained as a byproduct. So this type, first type, this is the first alkaline fuel cell used by in Apollo mission as a, by NASA in 1960 in Apollo series and the space shuttle. Alkaline fuel cell also used in military and space satellite applications because of to stationary generators. To construct these stationary generators, their alkaline fuel cells are used. So in military applications, satellite application, they're also used, and mostly space program. There since 1960, they're used alkaline fuel cell. Then second one is a phosphoric acid fuel cell. Okay, phosphoric acid fuel cell. So in a phosphoric acid, this first phosphoric acid fuel cell is commercialized. It is considered the first generation of modern fuel cell. After alkaline, first discovered the alkaline fuel cell, and then most of the researchers, then after later that researchers are focuses on acidic fuel cell also. Okay, so initially they use phosphoric acid, therefore phosphoric acid fuel cell. This type of fuel cell is typically used for stationary power generators. Stationary power generator as like generator, diesel generator, similar to that, their stationary power generator, their phosphoric acid firstly used commercially, commercial basis, they're firstly used phosphoric acid fuel cell. Now here question are why they called as a phosphoric acid. Okay, phosphoric acid fuel cell. uh, so in this case, there also oxidation reduction reaction takes place. If you see the construction of phosphoric acid fuel cell in this schematic diagram, there also anodic cathodic compartment or anodic cathodic electrodes are used. Okay, for construction of phosphoric acid. So anodic electrode, they are porous carbon material. Nowadays, instead of porous carbon material, graphite material or graphene oxide, reduced graphene oxide, also they are used or they use for construction of anodic cathodic electrode. Okay, so then previously they used carbon material, porous carbon material, and on the surface of porous carbon material they coated fine platinum powder. Okay, and the both electrode, anode cathode electrode, they constructed by using of carbon porous carbon material, and on the surface of porous carbon material they coated fine platinum powder. Okay, so platinum they acts as a catalyst there. Okay, in both cases. So between two electrodes, these are electrodes, anodic electrode, and second one is cathodic electrode. So from the anodic compartment, there hydrogen gas, here hydrogen as a fuel, they are supplied to the anodic compartment, and from the cathodic compartment means right hand side, here oxygen is supplied to the. So hydrogen oxygen both simultaneously supplied to the fuel cell. Okay, means oxygen, pure oxygen, or from air also their oxygen is used in a fuel cell. Okay, oxygen here from the right hand side, here oxygen supplied to the uh, cathodic compartment, and from anodic compartment their hydrogen gas supplied to the anodic compartment. So in this case their hydrogen gas is oxidized. Okay, but between two electrodes they use phosphoric acid. This is a carbide material actually. Between two, instead of electrolyte solution, in previous case alkaline fuel cell their NaOH KOH 70% or dilute NaOH is placed between two electrodes, but in this case their porous in this case their carbide material, carbide matrix material, and on the surface of matrix material their phosphoric acid electrolyte solution, silicon carbide matrix they're placed between two electrodes, and they're place the liquid phosphoric acid. Okay, liquid phosphoric acid, and both electrodes are made up of platinum electrode. Okay, porous carbon material coated platinum electrode. So at the here with how to generate electricity. Okay, in this phosphoric acid fuel cell there also they produce electricity. So in all fuel cell, their main purpose of fuel cell to generate electricity, not water. Okay, water they are obtained as a byproduct. This water is also possible to use domestic industrial purposes also, but main purpose of fuel cell to generate electricity. Okay, so in this fuel cell, phosphoric acid fuel cell, there also oxidation reduction takes place at anodic compartment, simultaneous reduction reaction takes place at cathodic compartment. Okay, always oxidation reaction. Most of the chemistry people, chemistry physics people, they know the oxidation, or engineer also they know the oxidation reaction always takes place at anodic compartment, anodic electrode, and cathodic reaction takes place cathodic compartment or cathodic electrode. Reduction reaction takes place at cathodic. Oxidation means loss of electron. Okay, and reduction means gain of electron. Always remember, all means all, already all of you familiar about this oxidation reduction reaction. Oxidation means loss of electron, reduction means gain of electron. So at the anodic compartment here, hydrogen gas means hydrogen fuel oxidize. Okay, hydrogen fuel oxidize into twice H plus twice electron. So electrons are released after oxidation, and these electrons moves from anodic to cathodic compartment here. Electrons, while traveling electrons or migrating electrons, these electrons capture or utilize as an electricity. So these electrons here it travels from anodic to cathodic compartment through the external circuit. Here electrons are comes out, and in presence of electrons, here reduction reaction takes place. Means oxygen here with in this case here oxygen is reduced. Okay, so oxygen and 4H. So after oxidation, what happen here? Here hydrogen gas is oxidized here. Okay, hydrogen gas is oxidized, electrons release. So there 4H plus or twice H plus form, and this H plus ion simultaneously travels from this anode to cathodic compartment through the membrane or through the carbide matrix. Okay, H plus ion travels from this anode to cathodic compartment through the carbide matrix. Okay, and this H plus again accept these electrons at the cathodic compartment, and H plus accepts electron means reduction reaction. So generally or always at the cathodic compartment the reduction reaction. So this H plus accepts oxygen electron, sorry, in presence of oxygen. So their water molecule there form. Okay, water molecule. So O2 oxygen 4H plus. This H plus comes from anodic to cathodic compartment. Also electrons they travel from anodic to cathodic compartment. This H plus accept these electrons, accepts of electron means reduction in presence of oxygen. So their water molecule form. So sorry, water they are obtained as a byproduct. So overall reaction is H2O2, water they are obtained as a byproduct, and they produce electricity after oxidation. Okay, oxidation at anodic compartment. So these reactions are found or takes place in a phosphoric acid fuel cell. So this phosphoric acid fuel cell called as because of their phosphoric acid is liquid phosphoric acid, which is placed between the carbide material, silicon carbide material. Okay, so called as a phosphoric acid fuel cell. So first time this phosphoric acid commercially used for as a stationary generators or predominantly natural gas operating on various fuels. This type of fuel cell used in stationary power generators, finding application in large vehicles such as buses, trucks. Okay, so this type of fuel cell they used phosphoric acid first time commercially for vehicles also. Then next is a molten carbonate fuel cell. So in this molten carbonate fuel cell also their oxidation reduction both reactions simultaneously takes place at anodic cathodic compartment. Anodic cathodic compartment both reactions. So as I told previously, in fuel cell, there are four major components are used. One is the anode, second one is the cathode, third one is the electrolyte solution, fourth one is the catalyst. So these four major components are required for construction of fuel cell. In this case, molten carbonate fuel cell. So why called as a molten carbonate fuel cell? Because of between these two electrodes, there place carbonate solution. Carbonate solution there place between two. So mixture of carbonate solution, lithium carbonate and potassium carbonate solution they place between these two. Electrolyte solution. Okay. Mixture of lithium carbonate, potassium carbonate. This mixture of carbonate solution placed between these two electrodes. These two electrodes here with made up of nickel chromium. Generally, in previous phosphoric acid fuel cell and in alkaline fuel cell, their porous carbon material is used, coated by platinum catalyst. But in this case, their alloys for construction of molten carbonate fuel cell, their nickel alloy, nickel chrome alloy, okay, or nickel aluminum alloy, or nickel aluminum bromine alloy is used as an electrode. Okay, and cathode electrode is the lithiated nickel oxide, magnesium oxide is used. Okay, and between two they placed molten carbonate solution. So mixture of lithium carbonate and potassium carbonate solution they placed between molten carbonate means in liquid form this carbonate solution placed between these two electrodes. So as usual, from left hand side here, hydrogen gas is passes or anodic compartment there passes hydrogen gas as a fuel. Okay, so in fuel cell, there hydrogen is used as a fuel and oxygen is used as an oxidizing agent or oxidant, pure oxygen. Okay, so hydrogen here passes toward the anodic compartment from left hand side or from anodic compartment. Here it passes hydrogen simultaneous oxygen to the supply to the cathodic compartment, and then their oxidation reduction reaction takes place. As so at cathodic compartment there CO2 O2, initially their oxidation reaction takes place at anodic compartment. Here oxidation hydrogen gas is oxidized in presence of CO3 carbonate ions. Okay, hydrogen gas here with oxidized in presence of carbonate ions. So here carbonate ions, and then they release H2, means water there obtained as about H2O, CO2, and electrons are released after oxidation of hydrogen at anodic compartment. Anodic compartment means in this anodic compartment, here hydrogen gas is oxidized in presence of carbonate ions. So there is CO2 electron and 4H plus 4 electrons are released there. And these electrons, after oxidation of hydrogen in presence of electrolyte, in presence of electrolyte solution or carbonate solution, carbonate ion solution, their electrons are released, and these electrons move towards cathodic compartment through the external circuit. These electrons, after oxidation of hydrogen in presence of electrolyte solution or carbonate ion solution, this hydrogen gas is oxidized and electrons released, and these electrons moves from anodic to cathodic compartment through the external circuit. While traveling electrons, these electrons utilize an okay, and these electrons goes toward the cathodic compartment. So at the cathodic compartment the reduction reaction takes place. Reduction reaction means gain of electron or accepts electron, so that's why these electrons moves toward the anodic to cathodic compartment. So these electrons accepted by this oxygen from left and right hand side, the oxygen gas supply. Okay, oxygen, pure oxygen or oxygen from air, they're supplied to the right hand side or cathodic compartment. So oxygen in presence of CO2, they accepts electron. Again, CO3 2 minus ions form, and this CO3 2 minus ions balance the electrolyte solution which is placed between the anodic cathodic compartment. So here CO3 2 minus ions form, and this CO3 2 minus again travels from cathode to anode compartment. So CO3 2 minus ions here with acts as a charge carrier ion. This CO3 2 minus. So this type of oxidation reduction simultaneously takes place between anodic cathodic compartment respectively, and then they produce electricity as well as water as a byproduct. Okay, so this type of mechanism involved in a molten carbonate fuel cell. So generally molten carbonate fuel cell is used for stationary power generators, as like diesel generators there, for construction of power generators, stationary power generators, they use the molten carbonate fuel cell, and this fuel cell is used industrial as well as military applications. Then a polymer electrolyte membrane fuel cell, here with polymer electrolyte membrane fuel cell. So this polymer electrolyte membrane fuel cell work as like phosphoric acid fuel cell. In phosphoric acid fuel cell, they use phosphoric acid, which is placed between two anodic cathodic electrode. Okay, but in this polymer electrolyte membrane cell, their polymeric membrane they're placed between two electrodes. Instead of any electrolyte solution, they place polymeric material, means sulfuric acid, like that polymeric membrane they place, and on the polymeric membrane there H through the polymeric membrane the H plus ions travels from anodic to cathodic compartment after oxidation. So in the polymer electrolyte membrane fuel cell at the anodic compartment there hydrogen gas supply. Okay, hydrogen as a fuel they supply to the anodic compartment. So in the polymer electrolyte membrane also these two electrodes are made up of porous carbon material coated fine platinum powder. Okay, these two electrodes, anode electrode, this one is the cathodic electrode. These two electrodes are made up of porous carbon material coated their platinum powder as a catalyst. And between two electrodes, they're placed polymeric, means these two electrodes connected by polymeric thin layer of polymeric material. Okay, so polymeric membrane fuel cell called as. So from as usual from anodic compartment or to the anodic compartment, they supply the hydrogen gas, hydrogen, and this hydrogen is oxidized. So after oxidation, their electrons are released, hydrogen oxidized, for example, twice H plus. Here, this type of reaction, hydrogen is oxidized, twice H plus, twice electrons are formed. And this, after oxidation, these electrons travel from anodic to cathodic compartment. While traveling electrons, these electrons are captured as an electricity or utilized as an electricity. Okay, simultaneously, what happened here? H plus ions, hydrogen is oxidized into H plus electron minus. So H plus ions they travel from anodic to cathodic compartment here through this. So H plus ion is a charge carrier ion here, and this charge carrier ion travels from anodic to cathodic compartment through the membrane. So this H plus ion reaches toward the cathodic compartment. Simultaneously, electrons moves towards anodic cathodic compartment. Okay, so this H plus ion accepts electron at cathodic compartment. This H plus accepts electron in presence of oxygen. Okay, H plus accepts electron means reduction. So reduction reaction occur at the cathodic compartment in presence of oxygen, and then the water molecule form and water here is released. So this oxidation at anodic compartment, reduction at cathodic compartment, both reactions simultaneously takes place in the fuel cell, and continuously they generate electricity and they obtain water as a byproduct. So this type of mechanism involved in the polymer electrolyte membrane fuel cell. Okay, so at cathode, if you see O2 in presence of oxygen, hydrogen ions accepts electron, then water molecule form, or oral reaction O2H2 plus plus H2 their water molecule. So this type of continuous reaction takes place in this polymer electrolyte membrane fuel cell, and they produce and then obtain electricity as well as water as a byproduct. Another one is the solid oxide fuel cell. Solid oxide fuel cell, as like solid oxide water electrolyzed here with also they're used yttrium stabilized Syria solid oxide material they're placed between two electrodes. Between two electrodes they're placed yttrium stabilized Syria material they're placed, and through the solid oxide, through the here means not called as a membrane, but their solid oxide material they're placed yttrium stabilized Syria material, and through this yttrium stabilized Syria material there passes O2 minus ions. O2 minus ions here with passes from cathodic to mm, from cathodic to anodic compartment, and here with also oxidation reduction reaction takes place in both compartment. But here O2 minus ions travels from cathodic to anodic compartment. Therefore, solid oxide fuel cell called as a so oxide ion is a charge carrier ion which is travel from oxide ion. O2 minus ion is a charge carrier ion which is travels from cathode to anode compartment. And simultaneously here oxidation reduction reaction. So from the anodic compartment here, hydrogen gas is passes. Hydrogen gas, okay. Hydrogen gas is oxidized and electrons release. This electron travels from anodic cathodic compartment. This electron accepted by oxygen O2 minus form. O2 minus again they travel from cathodic to anodic compartment. So this type of oxidation reduction reaction, if you see in this case, H2 plus O2, H2O twice electrons means hydrogen gas is oxidized at anodic compartment in presence of O2 minus ion, and their twice electrons are released and their water molecule form there. Okay, so at cathodic electron, cathodic compartment, what happen? O2 minus here, electrons release after oxidation, electrons release from anodic cathodic compartment, and oxygen accept these electrons, O2 minus ions form. So reduction reaction called as O2 accepts electron, reduction reaction accepts means O2 minus form. This O2 minus again they travels from cathode to anodic compartment through the Syria material or yttrium stabilized material, means solid material this one, and through this solid material their O2 minus they travels or migrates. Therefore solid oxide fuel cell called as O2 minus. Again the O2 minus in presence of hydrogen, their water and electrons released. So this type of oxidation reduction both are found in anodic cathodic compartment or anodic cathodic electrode respectively, and they generate electricity and they're often water as a byproduct. So this type of solid oxide fuel cell is used power stationary generators in home as well as in business, as well as uh, gas turbines. Okay, uh, and used in gas turbine or spin turbines used in stationary power generators. So generally 1 kilowatt to 25 kilowatt and their heat energy produced, sorry, electricity produced from the solid oxide fuel cell. Okay, so advantage of fuel cell. Uh, Fuels. The fuel cell shows the high efficiency of energy conversion, approximately 70% from chemical energy to electrical energy. Here, chemical energy means hydrogen is used as a chemical, okay, not chemical like alkaline solution, phosphoric acid solution, or any other polymeric membrane, not considered as a chemical. Here, chemical energy means hydrogen gas. Here, used as a chemical or fuel here, okay. So chemical energy converted to electrical energy in this fuel cell, okay. So there very low noise pollution generally in, if you see diesel engine generators or power station, they produce their noise highly, but there no any noise pollution, no noise pollution, or very low thermal pollution. Fuel cell power can reduce expensive transmission lines, minimize transmission losses of disturbed system. Fuel cell gives the excellent method for efficient use of fossil fuels, then saves fossil fuels. Okay, so it is one of the fossil fuels replaced, the fuel cell replaced the fossil fuels. Fuel cell are less polluting or generally no any CO2, CO or SOx, these gases not produced, okay, by this fuel cell. So they're just water, they're obtained as a byproduct. So in case of fossil fuels, when used, environmental hazardous NOx are produced, but in this case, there are no any NOx, SOx are produced in this fuel cell. In the hydrogen oxygen fuel cell, produce drinking water. They are possible to use. Means in 1960, their Apollo mission, they used first alkaline fuel cell. So their electricity produced as well as water, they are obtained as a byproduct. And the astronauts, they use this such type of water for drinking purposes also. Okay, so they use water, they are obtained, water produced or water obtained as a byproduct. This byproduct water is used for drinking purposes or potable purposes also. Designing is a modular, the input parts are exchangeable, low maintenance cost, fuel cell purpose is Indian power plant size, fast startup time for low temperature system. The heat is cogenerated, hence increase efficiency. Nowadays, researchers are focuses to how to increase efficiency of fuel cell by using of various types of catalysts like nanometal catalyst, or some of the pure nano particles like silver, gold. Instead of that, they focuses the composite nanoparticle like iron oxide, BI4, BI4, TiO2, BI4, like that. Okay, so that's why maybe hopefully in coming days their efficiency going to enhances. The demand for variations in power energy densities is easily made required. For example, laptop, computer also low power density, high power density, whereas automobile requires high power density, high energy density. Both can powered by fuel cell. Fuel cell automotive batteries can render electric vehicles efficient, refillable. Okay, now if you see in Europe countries, in Germany or USA, there or they're used hydrogen fuel. Hydrogen fuel, they are using in a fuel cell, and they for transportation means railway engines, truck buses in Germany or mostly in Europe, their hydrogen fuel cell, with the help of fuel cell, the transportation now running on. Okay, so the first commercial fuel cell is used. Fuel cell was in NASA, as I told previously. So nowadays they are used to power fuel vehicles, including automobiles, aeroplanes. Aeroplanes yet now not used, but in future they're possible to use fuel cell. Okay. So instead of fuel cell, nowadays researchers are focuses on internal combustion engine also. Directly they can use hydrogen. Okay, like petrol, diesel, kerosene directly used na in internal combustion. Similarly, there hydrogen possibly. So in Toyota Mirai company, there also they focuses on internal combustion engine where directly their hydrogen is used. Okay, so with this whatever I collected all data from the internet as well as from textbook also, chat GPT also. So I'm very much thankful to all these things. So I'm very thankful to all participant delegates for kind patience. listening my this talk. Okay, thank you very much.
Thank you, sir. I just request for all the participants, if you have any query, please ask. Am I audible?
Yes, madam.
So,
Uh,
anyone
If you
have
have
any
queries, then
query?
you can ask
Please
anyone. Or just
interact with sir.
now I'm focusing in my laboratory. I'm working on hydrogen also, for production of hydrogen by electrocatalysis. So anyone interested may collaborate. I am also interested for collaboration or regarding the production of hydrogen by electrocatalysis or synthesis of catalysis. If anyone interested, they can join with me or ask me anytime. I will help you as per my knowledge.
मला प्रश्न आहे.
Hi, yes, sir.
Sir, very, sir, very
Huh.
good evening to one and all.
Okay, sir.
Uh, uh, Ganesh sir, you explain this new source of energy in very nice manner.
Thank you.
Am I audible to you, sir?
Yes, yes, yes.
Uh, so my question is that in the this is very recent topic and it is very interesting. Though I am not directly connected, or this is not a direct topic of my interest. But then too,
Yes,
it is very recent topic. So that's why I joined this particular FDP. So my
yes,
question
sir.
is, sir, in spite of having the need of this hydrogen energy, and one of the major issue for the energy source. Why in India? What are the various challenges in India to produce the hydrogen gas in mass production? So, in national or international level, it is one of the hot topic, and in every
Yes.
country, or almost all in every country, they are going for the hydrogen energy or hydrogen gas production. And
Hmm.
in that race, India is also not too much behind, but then too we are unable to produce the hydrogen energy in that much source. So as you explained in the very first slide, our total contribution of hydrogen energy is only 10%, or we can
Yes,
say
yes.
less than
Hmm.
10 also.
Hmm.
So what are the challenges that we are facing in order to enhance the production of hydrogen gas or hydrogen energy in India especially?
Yes, yes. So, sir, recently what happened? Their hydrogen, we are telling that okay, hydrogen is produced from water. Just now I tell okay, first two three slides by electrocatalysis, photocatalysis. But what happens, sir? In the construction of water electrolyzer, there yet now there no no any sophisticated catalysis have been synthesized. Okay, so compared to platinum catalyst or gold catalysis, their platinum gold they are very costly. Okay, so they're not possible to use in large scale. Suppose we want to produce 1 kilogram hydrogen per day, so we need a lot of platinum. So their cost. They're very much high cost platinum or gold catalyst. So this type of catalyst if you use they're not possible to generate uh, uh, hydrogen. Okay, 1 kilogram 2 kilogram per day. So this type of method is not sophisticated. And another thing, suppose we are going to just now we are synthesize various types of catalysts in India. In India, or some research institute, they are focusing on catalysts only. Only their components, whatever components are required. For example, bipolar
संजूला
plates,
फोन कर.
cathodic electrode, anodic electrode, they are easily available. But catalysts are important one. And in research institutes, mostly catalysts they are synthesized. But as we required, for example, suppose 500 gram or 1 kilogram, this type of catalyst is not yet no not synthesized in our India, even abroad also. But whatever they have catalysts, they are using in electrolyzer. And another thing is that their electricity also they require external electricity. Okay, in photocatalysis there not efficiently hydrogen gas is produced, so mostly the researchers are used electricity. So where it comes
चला.
from electricity, again this is one of the issue, because of we are focusing on hydrogen energy, and hydrogen energy is used for production of electricity. Okay, so again in electrolyzer there again electricity is required. So how it generate electricity? So again will come from nuclear energy or thermal energy, whatever the electricity use. Okay, so This is some issues nowadays we are focusing, but solar photovoltaic electrolyzer, solar energy, if you use electricity from solar energy, and then we produce hydrogen, and this hydrogen then after use for various industries as well as for fuel cell, then this is a suitable one. But solar cell also there is costly one. So this type of issues are raised in India also, because of we need solar panels, solar cells, or nuclear power plant for electricity, and this electricity we are going to be used for water splitting again. So this type of issues are raised in India also. So that's why firstly we want to focus renewable energy, how their solar cell or solar energy will produce electricity, and this electricity is much used for water electrolyzer. Okay, so maybe I hope in coming next 5 to 10 years we'll produce hydrogen in large scale. Okay, this is a not difficult one, but surely we'll develop this type of technology and will produce, okay, hydrogen in large scale. Hello sir.
Okay, sir. Thank you.
Okay, sir.
Okay. Thank you.
No, sir.
Sir.
Okay.
Any questions from audience, delegates, participants?
Sir, one more question from my side. Good evening, sir. Am I audible?
Yes, sir. Yes.
Uh, I want to ask you one more question.
Yes.
Sir, going for producing hydrogen energy or hydrogen gas. So in most of the methodology you have explained, we have to give some input in terms of say electricity or say heat energy.
Yes.
Is it fine? Is it fine, sir? Am I
Yes,
audible?
sir. Uh, what?
So in most of the cases, we have to give the input as heat energy or
Yes,
electric
yes.
energy.
From yes,
So
for
in
production of
that,
hydrogen. Okay, yes.
uh, so I'm talking about in terms of production. So is it not efficient because we have to give the output, major output, and we are getting the input in not that much of amount. So is it efficient to, as far as in small scale also to produce the hydrogen energy in right now in India?
Yes, yes, yes. This is possible to produce hydrogen because of if you India see most of the startup or most of the industries like Reliance Industries, Tata Industries, they are now produces hydrogen in small scale right now. Their R&D sector they produces hydrogen at small scale initially. Generally 1 kilowatt electrolyzer or 2 kilowatt electrolyzer they are now constructed, and then after at large scale they are analyze how much amount of hydrogen produce. Okay, so small scale it possible as like fuel cell now, their
Okay.
anode cathode. So for construction of electrolyzer 1 kilovolt electrolyzer, if you want to construct then it is possible one. So
Yes,
small
sir.
scale production of hydrogen is
Uh,
possible.
uh, at the end of the session, sir, kindly share your lab details so that I can contact you in future.
Yes, yes,
Thank
sure,
you.
sir. You
Okay,
can
thank
take
you so
my
much.
contact number from Mulani sir. Otherwise, in group, I have my contact number. You can come anytime or contact me. Okay, sir. Yes, sir. Yes, sir.
So actually, I thought there is no any doubt from anyone because you just elaborate all the things, sir, in deeply. So I just, behalf of my institute, I just thankful you to sir, because this is a wonderful session. You just elaborate all the basic things, and if no one is any doubts, so I just declare today's session is concluded. If you
Okay,
have
thank you.
anyone have any doubt, I just recall. Anyone have any doubt?
Yes, ma'am.
Oh, okay, 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 okay. Thank you, sir. Actually, this is you just
Uh,
elaborate all the
Madam,
things in
one
a
minute,
brief
please.
manner.
Madam, 1 minute.
Yes, yes, sir.
Before conclusion, uh, can I means have you taken
Yes,
any
sir, sure.
screenshots? Screenshots have
Yes,
you
sir, yes,
taken?
sir.
Okay, okay,
Sure, sure, sure.
okay. Then conclude.
Okay, okay. So thank you, sir. So on
Yes.
behalf of my institute, I just thankful to all the participants, also you, sir. So I declare that today's session is concluded. Thank you.
Excuse me, madam. Hello, hello, hello.
Hello. Yes, sir, yes, sir.
Madam, can we get attendance link? Hmm? Can we get attendance link, please?
Yes, sir, yes, sir. This will be shared on group, sir.
Yes, sir. Yes, sir. Yeah, yeah, yeah. And also attendance link, please. Attendance. Oh, okay. Thank you, sir. Thank you.